Good morning. Today we're going to review all of our factoring methods and then also talk about how to decide which method to use when factoring. So the first thing we're going to do is just go through some examples of each type, and then we'll come back and talk about how to decide when to use each method. This is also going to be in Empower. So when you open it up, it'll make a copy and put it into your drive so that you have access to this as well. So our first method we talked about was GCFs. And when we factor GCFs, there are 3 steps. The first thing is to identify the GCF for all terms, then write the GCF in front of a new set of parentheses, and then divide each term by the GCF by dividing coefficients and subtracting exponents. Do not forget a 1 if the GCF is the same as one of the terms. So when you divide things out, make sure you, if you start with 3 terms for GCF, you end with 3 terms in the parentheses. So if we look at this first problem here, we have factor 8x to the 4th minus 12x squared plus 6x. When I look at these, I know that all of those numbers are even, so I have an idea that I can divide by 2. And then just in checking, I can't, if I divide 6 by 2, the only thing left is 3, and I can't divide 8 by 3, so I know I can't go any bigger than that. Okay, so 2, and then I have to look at the variables. They all have x's in there, but the last term just has 1x, where this has 2 and that one has 4, and that's what those exponents represent. So I have to go with the smallest number of x's when I pull out my GCF. So my GCF is just the 2x. And what I'm going to do with that is I'm going to write it in front of the parentheses, and you actually don't have to write that middle step there. So I put a 2x here, and then to find out what's left there, I'm going to go step by step. 8 divided by 2 is 4. If I had 4 x's and I took an x out, I have 3 x's left. Negative 12 divided by 2 is negative 6. I had 2 x's. I took 1 out, so I have 1 left. And then 6 divided by 2 is 3. I had 1 x and I took it out, so I just have a 3 there. Okay, so that's your GCFs. The next method we learned was factor by grouping. Factor by grouping uses GCFs, so we're going to group the first 2 terms together in parentheses and factor out the GCF. We're going to group the last 2 terms together and factor out a GCF, and then check to be sure that the terms remaining in this parentheses match. If they do, we're going to pull them out front, and then whatever is left over, make the second group. So let's look at this. 5x to the 3rd minus 6x squared is going to go in my first group, and then negative 40x plus 48 is going to be in my second group. Okay, so I just put parentheses around those. Notice I put that negative sign in with that 40 because it's really important to have there. Then I found my GCF. The only thing that these first 2 terms have in common is an x squared. So I put an x squared out front. And if I take an x squared away here, I just have an x. And if I take an x squared away there, I just have a 6. And then my GCF for 40 and 48 is 8. But because this is a negative 40, I made it a negative 8. So 40 divided by negative 8 is 5. And 48 divided by negative 8 is negative 6. Now notice that my 2 groups match. So I pulled them out front, and then I had the x squared minus 8 in front of my parentheses, so those become my second group. The third method you learned is AC split. So what you're going to do is draw an x and label the coefficients as a, b, and c. You're going to multiply a times c and write your answer on the top of the x, write b on the bottom of the x. You're going to find the 2 numbers that multiply to give you the top and add up to the bottom and write them on the sides. You're going to rewrite your trinomial with 4 terms by keeping the first and last terms the same and then splitting the middle term using the numbers from the x. And then we're going to factor by grouping, which is what we just did. There's 3 examples of this because this is the most common method that you're going to use when you're factoring. So the first thing you're going to do is label a, b, and c. So a here is 1, b is negative 5, c is negative 6. And then a times c, 1 times negative 6, goes on top. And then the negative 5 goes on the bottom. And this one is one that students tend to make mistakes on. So I need 2 numbers that multiply to give me negative 6 and add up to negative 5. And right away, students think of negative 2 and negative 3. But negative 2 times negative 3 is actually positive 6. So my other option is a negative 6 and a 1. What we're going to do then is rewrite this as 4 terms. So x squared stays the same, negative 6 stays the same, and then the middle terms I split using the side numbers from my x. I'm going to make two groups like we did in the last type of factoring, and then factor out my GCF. So this first group only has an x in common. The second group only has a 1 in common. So if I take an x out of the first group, I'm left with x minus 6. If I take a 1 out of the second group, I'm also left with x minus 6. And notice my x minus 6's match, so I'm going to pull that out front, and then my x plus 1 goes in my last set of parentheses. Okay, some of you by now hopefully noticed a trend when there's nothing in front of my x squared. Once I find these two numbers here, they actually go right to my parentheses. But if you look at examples 2 and 3, that doesn't work. Okay, so for 2, a times c is 2 times 35, and that gives me 70 at the top. My b is 17, so I need to find two numbers that multiply to give me 70 and add up to 17. And I found 7 and 10. The order doesn't matter here, just be careful with your signs. Okay, so the signs will make a difference, the order doesn't. I'm going to use those two numbers that we just found to rewrite that with 4 terms. So the first term stays the same, the last term stays the same, and then I split the middle. I'm going to put that into two groups like we did for factor by grouping. And then in my first group, the only thing in common is an x. And in my second group, I can divide both of those by 5. So if I take an x out of the first group, I'm left with 2x plus 7. If I divide by 5 in the second group, I'm also left with 2x plus 7. So that's good. If those don't match, I made a mistake. I'm going to pull the 2x plus 7 out front, and I'm going to leave my x plus 5 in my second group. Okay, last one, same idea. 8 times negative 9 goes on top. 14 goes on bottom. This one took a little bit more work to find my numbers, and I actually just listed out 1 times 72, 2 times 36, 3 times 24, 4 times 18. And I knew if I had a negative 4 and an 18, I could get a positive 14. That's the trickiest part of these. Okay, write this with 4 terms. Again, the order doesn't matter, but the signs do. Put them in two groups, and then in my first group, I can divide by 2x. In my second group, I can divide by 9. So if I divide by, sorry, not 2x, 4x. If I divide by 4x, I'm left with 2x minus 1. If I divide by 9, I'm also left with 2x minus 1. And then in the last one, whoops, sorry. Yeah, I just uncovered all that. Let me go back. Okay, let me go back here. I'm gonna have to click through a bunch of these. Okay, so I divided by 4x in the first group and 9 in the second group. And then my 2x minus 1's matched. So I pull 2x minus 1 out front, and then the 4x plus 9 will make my second group. The last type of factoring we talked about was special cases. And really, one of the special cases is just like what we just did. The other one's a little different. So for difference of squares, you have to have two terms, and you have to be able to take the square roots of them, and there has to be a minus sign. So for this example here, I can take the square root of 9x squared to get 3x, and the square root of 16 to get 4. Since there's a minus sign in the middle, it always factors using this pattern. So I use my square roots that we just found. So the 3x and 4, 3x and 4, one's a plus, one's a minus. The one on the bottom, because it has 3 terms, I can actually use an x factor. So I'm going to put 25 on top, negative 10 on bottom, and the two numbers that multiply to give me 25 and add up to negative 10 are negative 5 and negative 5. Write that with 4 terms. Make two groups. Be careful with that negative sign. First group, I can take an x out. The second group, I can take out a negative 5. So when I do that, I'm left with x minus 5 in both groups. So when I bring that out front, I have x minus 5 times x minus 5, which I can write as x minus 5 squared. If you do not rewrite it as x minus 5 squared, you're still good. Okay, so now I want to go back to my which method. So in Unit 8, we learned 4 different approaches to factoring polynomials. How do we decide which one to use? Okay, so is there a GCF? Yes, you're going to factor that out. And then you're going to go check to see how many terms. If there's not a GCF, you go right to how many terms. If there's 2 terms, we're going to check for difference of squares. 3 terms, you're going to try AC split. 4 terms, you're going to try factor by grouping. Always at the very end, check to make sure that you do not have a GCF or another special case left over. Also, when you have this notebook, if you click on the links, you can go ahead and visit each of those pages to see the examples of the steps. If you have any questions, let me know. We will do some examples in the next video.